morning everyone. I am Sangram Assistant Professor of Electrical Department. So today I am going to tell you about that is Thevenins theorem. So first of all, what is Thevenins theorem? So in any here we study for DC network. So for any DC network containing voltage source, current source as well as load resistance, it can be replaced by this equivalent circuit containing Thevenin voltage, Thevenin resistance and load resistance. So this one is the main circuit. This one is the main circuit, and this one is the equivalent Thevenin's equivalent circuit. Thevenin's equivalent. So that means any DC network, okay, containing load resistance RL, it can be replaced by Thevenin's equivalent circuit which contains VTH, RTH and RL. This is the Thevenin's equivalent circuit. Now I will solve one problem so that you can easily understand. So let me start. So suppose I am taking here, this one is the one example, this is one example. Okay, here suppose voltage is 10 volt, here resistance is 1, here 2 ohm, this is 3 ohm, and here this is suppose 4 ohm. Okay, now what we have to do, by using Thevenin's theorem, we have to find out current through, that is 3 ohm resistance, that is this is the IL, and here RL is equal to 3. Okay, we are finding out current through 3 ohm resistance. That's why this one is the load resistance RL. Okay, and here we have to find out what IL. IL we have to find out by using Thevenin's theorem. So what is the first step? So first step is we have to find out VTH. So step 1, that is for VTH. Okay, so for VTH, what is the procedure? So first you have to remove the load resistor. That means open circuit the load resistor, and you have to find out voltage between that terminal. So now the load resistor is this one is RL. So simply in the main circuit you have to open the load resistor, and across that you have to find out VTH. That means VTH or VOC or open circuit voltage. So that means that is the VTH procedure to calculate VTH. So here, so I have to draw the circuit first. This one, your load resistance, you have to open circuit like this. Here, all other things will remain as cell. This one is the open. Here is VTH, you have to find out. This is plus, this is minus. VTH, or you can write VOC. Okay. So now this one is the 10. This one is the 1, this one is 2, 4. All other things will remain same. Simply you have to open the load resistance RL. You have to find out voltage across that. So how will you find out voltage across this? Just see. So suppose I have to apply KVL here, so that I can easily get VTH. Either you can apply KVL here or you can apply KVL here. Okay. So to calculate VTH. So if you apply KVL here, so we need current here. So first find out the current. Okay. So how we find out the current? That's why you have to apply KVL in this way. Okay. So if you apply KVL here, so what will happen? This one negative to positive reserve potential, that is cross 10. Suppose your current is just I. Okay. So here current I means here current I. Okay. This one is the current I. So now 1 minute. Because this one is the open circuit, that's why the same current flow through this one. So first calculate current I by using KVL. So 10 minus 1 into I, that is I, then minus 2I, then minus 4I, which is equal to 0. This implies I is equal to, here I is equal to, this I plus 2I plus 4I, 1 plus 2, 3 plus 4, 7I. That means you can write 7I 10 minus I. This is equal to 10 minus I. I means how much you got? That is 10 by 7. So this is equal to 7. This is 70 minus, that is 10. That means 60 by 7. So that is 4. So you are getting VTH is equal to 60 by 7. Okay. So this is the procedure to calculate VTH. Okay. So only you have to open the load resistance RL and you have to calculate voltage across that is VTH. So VTH part is over. Next we have to calculate RTH. Okay. So next is RTH. So I am deleting this part. So VTH is just note down 10 by 7. Okay. So we got how much VTH is equal to 60 by 7. So this one is the VTH. Next what we have to do in the step 2 we have to calculate RTH. So this is step 2. Step 2 this is for RTH. So to calculate RTH, what is the procedure? So whenever we are calculating VTH, what is the step? We are simply open circuiting load resistor. Okay. Now whenever you will calculate RTH, you have to do two things. So first is we have to open circuit the load voltage. Second thing, and all other source you have to replaced by its internal resistance. Voltage source will be replaced by short circuit. Okay, and current source will be replaced by open circuit. Okay. So this is I am telling ideal voltage source and current source. Okay. So now let's see. So RTH circuit I am drawing. So here resistance it will be as usual. We will keep like this. 1. This is 2. This is 4. You have to keep as usual. And this is load resistor. You have to open circuit. This one is the load resistor. You have to open circuit. And this is the voltage source. Voltage, this is the ideal voltage source. It will be replaced by its internal resistance. So its internal resistance is 0. That's why it will be replaced by short circuit. So that means short circuit. And here from this terminal we will calculate RTH. Okay. Now let us see 2 and 4. These are series and 1 is parallel to other. So that means whenever you are calculating RTH, so it will be 2 plus 4 parallel to 1. That means 6 parallel to 1. So that means 6 into 1 divided by 6 plus 1. This is 6 by 7. So this one is the RTH. Okay. So step 1 VTH over, step 2 RTH over. Now we will go to step 3. That is the final step. Okay. We are getting RTH is equal to 6 by 7. So VTH we got in step 1, VTH we got in step 2, RTH we got. Now we will go for final step. That is final step. In final step, what we have to do? We have to calculate load current. That is I. Okay. So first, let me draw the equivalent circuit of this circuit. Thevenins equivalent circuit. That is here. This one is the Thevenins equivalent circuit. VTH in series with RTH. Which one is connected with load? So here, this is the Thevenins equivalent circuit. And here, what is the value of load resistance? Load resistance in of 3. This one is 3. Okay. This is what? RL. Okay. Here, this one is the IL. And this IL you can calculate. IL is equal to total voltage is VTH divided by RTH plus RL. Okay. So already we got VTH. VTH is how much? Is 60 by 7. Here 60 by 7 divided by RTH. RTH is how much? 6 by 7. Here this is 6 by 7 plus that is RL. RL is equal to how much? 3. Now you have to calculate this. Okay. So now here you can write. Here you take the extent 3, 7. Okay, you can calculate also in the